Good morning, everybody. We are talking today about rates and specifically unit rates. Our second question is, what is a unit rate? What makes a rate a unit rate? We'll talk about what that means. So a rate is a ratio that compares two quantities with different units. So we talked about this a little bit yesterday. How the difference between a ratio and a rate is that rates have different units. And remember again, that doesn't just mean like seconds versus minutes, because those are both rates. Those are both units that measure time. We're talking about different units, as in one measures time and one measures distance, or one measures volume and one measures people, right? So it's fundamentally different units that are measuring different things. Okay, that is what a rate is. So if you go like 200 miles in 3 hours, then 200 miles in 3 hours is a rate. Okay, a unit rate is the rates you're probably most used to hearing. And unit rates are rates that have been simplified so that the denominator is 1. Okay, and you see unit rates all around you. Probably the most common is speed limits. And if you're going down the street and you see a speed limit sign of 55, that means 55 miles per hour is the limit for your speed there. So how many miles you can go in 1 hour. Okay, it doesn't say 110 miles per 2 hours, right? That would be a rate, but not a unit rate. It tells you how many miles per 1 hour. Okay, so it's simple. I always simplify so the denominator is 1. If you take a minute, you might be able to think of other ones that you've heard. With cars, sometimes you hear miles per gallon. That's how many miles I can go on a single gallon. It tells you how efficient they are with fuel. If you go to the gas station, there will be a price in dollars per gallon. So how much per 1 gallon gas costs. And there's many more. So lots of different rates. Unit rates are simplified so the denominator is 1. And we'll see more as we go through the examples we have. Before I get into some examples, though, I want to play you a video and introduce you to Rady the Math Cat, who's going to help you remember that with rates, we've got to purr. Enjoy. All right, welcome back. Hopefully that video about Rady completely changed your life like it did mine. I think it's kind of fun, and it's a good way to remember that anytime we're dealing with rates, it's always this per that. So we're always having two different rates, and we're going to be labeling them with a per in between. All right, so let's look at our first example. Sam reads 141 pages in 3 hours. How many pages does she read per hour? So what we have right now is a rate, right? 141 pages. 41, and this is pages, in 3 hours. That is a rate, 141 per 3. That is not, however, a unit rate. Remember, to get it to a unit rate, we need the denominator to be a 1. Okay, so I don't want to know how much she reads in 3 hours. I don't know how much she reads in 1 hour. Okay, so in order to do that, to get from 3 to 1, remember what we know about equivalent fractions. I'd have to divide by 3. Okay, well, that means I divide the top by 3 also. Okay, 141 divided by 3. If I bring that over here, 3 does not go into 1. It goes into 14 4 times. 3 times 4 is 12. Subtract, I get 2. Bring down the 1. 3 goes into 21 7 times. So it goes in exactly. Nothing left over. All right, so 47. So if I divide by 3, I get 47 pages in 1 hour. Okay, so the way that I can say that, now that I have the 1 on bottom, I don't need to say the 1 because it's just in 1 hour. I can say it's 47 pages per hour. Okay, so just like miles per gallon or dollars per pound, whatever it is, just say that the top unit per the bottom unit. Okay, 47 pages per hour is how fast she's reading. All right, so get another one. On a trip from Columbus, Ohio to Myrtle Beach, South Carolina, Lee drove 864 miles in 14 hours. What was Lee's average speed in miles per hour? Okay, so again, I can write the rate 864 is the number of miles that he went. And he did this in 14 hours. Okay, so 864 miles per 14 hours is a rate, but I want to make that a unit rate since I need to divide. Now, the shortcut here, if I want to get this down to 1 hour, well, I know to get this 14 down to 1, I have to divide it by 14. And I have to divide the top by the same thing. So what I'm actually doing here, you may have noticed this on the last one, is just like when I turn fractions into decimals, all I'm doing is dividing the top by the bottom. If it's 864 miles in 14 hours, I don't know how many miles I go per hour. I just have to divide this by the number of hours. So this divided by 14. So turning a rate into a unit rate is always just going to be dividing the top by the bottom. Okay, so I can bring that over here, 864 divided by 14. Okay, well, 14 does not go into 8. It does go into 86. If we're wondering how many times, my guess maybe 5. If you do 14 times 5, you get 4 times 5 is 20. 1 times 5 is 70. So 70. So 5 14s would give me 70. If I think about adding another 14 to that, 70 plus another 14 would be 84. Okay, well, that gets me really close to this without going over. All right, so I can fit one more, and I can fit in 6 14s. Okay, and 6 times 14 is 84. Okay. Subtract, I get a 2, bring down a 4. Okay, now 14 goes into 24 one time. 1 times 14 is 14. Subtract, I get 10. Okay, and I can keep going. Remember what we do with decimal division here. I can add a 0 and bring it down. 14 into 100. You might guess maybe 7. So let's try 7. 14 times 7 is 28. So 98 that gets me real close. Decimal point stays there. I got 7. You subtract 98, I get 2. You can add another 0 to bring it down. 14 goes into 20 one time. Okay, and I could keep going. I don't necessarily need to get an exact answer here. I can tell it's going to keep going for a while, give me a few decimals. This is one that will eventually repeat, but it'll take a while for it to repeat. So in general, if we get a couple of decimal points and round it off to 1 or 2 decimal points, that should be fine. Okay, so 61.7, this 1 tells me I would round down. So if I round out to 1 decimal point, I just get 61.7, and that's probably good enough. Okay, so the unit rate here is about 61.7 miles per hour. Again, I want to say about because it's not exact, but that's okay. About 61.7 miles per hour is plenty. All right, so here is an example of how this stuff is used a lot of the times. A lot of times, unit rates are used to compare. Okay, so in this case, you have an option to spend $12.50 for 2 pounds of almonds and $23.85 for 5 pounds of jelly beans. Now I want to know which item costs less per pound. Okay, it might be hard from those numbers to tell which is the cheaper food, because for almonds you're paying less, but you're also getting less. For jelly beans you're paying more, but you're also getting more. Okay, if you have good proportional reasoning, you might be able to tell which is the better deal. But depending on how close the numbers are, it might not necessarily be obvious. So the way to compare these things is to get a unit rate, figure out how much it costs per pound. Okay, once we know how much a pound costs for each one, then it's easy to compare. So let's start with almonds. Okay, he spends $12.50 for 2 pounds. Okay, $12.50 for 2 pounds. Okay, so I want to know the unit rate. That means I'm going to do $12.50 divided by 2, which I can do that in my head. That's $6.25 per pound. Okay, so $6.25 per pound is my unit rate for almonds. Okay. If you're not sure which number to divide by which, remember I'm trying to find the cost per pound If you want the cost per pound, you have to divide it in that order. Cost divided by pounds. Okay. For jelly beans, I want the cost per pound there. So the cost is $23.85. And that gives me 5 pounds. So $23.85 divided by 5. That's going to give me the cost per pound. Okay, so $23.85 divided by 5. If I do that quick in my head, you can check me. I'm getting $4 and 77 cents. Okay, $4.77. Okay, so go ahead and check me. That's what I'm thinking. So $4.77 per pound is what I'm getting here. Okay. All right, so did I answer the question? I found a unit rate for each. It asked me which item costs less per pound and by how much. So it's asking me two things here. Okay, so which costs less per pound? That's the jelly beans. Okay, $4.77 is less than $6.25. It also asks by how much. So that means I need to figure out the difference between these rates. So if I do $6.25 minus $4.77, I get $1.48. Okay, again, you can check that if you'd like. I'm pretty confident in that one. So, jelly beans cost less. They cost less by $1.48 per pound. Okay. All right. So let's try another one of those. So Cameron spends $22.50 for 2 pounds of peanuts, $31.05 for 3 pounds of cashews. Which item costs less per pound and by how much? Okay. So I want the unit rates on peanuts. Peanuts are $22.50. And that's dollars for 2 pounds. If I want to make the unit rate, I got to divide. $22.50 divided by 2 is $11.25. Oh. $11.25 per pound. Okay, for cashews, it's $31.05 for 3 pounds. So $31.05 for 3 pounds is my rate. To make that a unit rate, I have to divide. I get $10.35 per pound. Okay, so this one was a lot closer, but this is the cheaper fruit. Cashews are less per pound, smaller amount per pound, so you get the same amount of food for a smaller amount of money. So cashews are the better deal. Okay, if I know how much, I got to subtract. $11.25 minus $10.35 is 90 cents per pound. It's 90 cents per pound cheaper. I should get that by subtracting. Okay. All right. So I'm going to pause here and let you try to figure out which one you think is the better deal. Okay, an 18-ounce box of cereal for $3.96 or a 24-ounce box for $4.80. So you want to find the price per ounce and figure out which is the cheaper price per ounce. Okay, so take a minute to figure that out, and we'll continue on. All right, let's check in. So hopefully these are the values that you got. $3.96 for 18 ounces. If I want the price per ounce, I take the price, divide by the number of ounces. I get 22 cents per ounce. Okay, so each ounce of this cereal costs 22 cents. Here, if I want the price per ounce, I take the price $4.80 divided by the ounces, which is 24, and I get 20 cents per ounce. Okay, so 20 cents per ounce is cheaper than 22, so this is the better deal. Okay, you'll find that a lot as you get older and start shopping for your own groceries. Usually you'll get a better price per ounce on bigger sizes of food, okay, to try to encourage you to buy more food. They make it a little bit cheaper per ounce, a little bit better value. That's not always the case, so it's good to always check and make sure you know how much you're paying per ounce or per pound or whatever you're buying. All right, so one more of those. So let's say you're buying laundry detergent. You can get 64 ounces for $4 or 96 ounces for $6.24. So go ahead, pause the video, decide which one you think is the better buy, and we'll see if you're right. All right, welcome back, everybody. This one was super close, but in this case, the 64 ounce was the slightly better buy for $4. Okay, it was about 6 cents per ounce instead of 7 cents per ounce. Now, I want to point out something because it came down to rounding here. Here, remember, anytime you're dealing with money, you want to round off to 2 decimal places, right? Because we have dollars and cents, but you don't pay a fraction of a cent for anything. So this came down to $0.0625, which if I round up to 2 decimal points, okay, that's right here. The hundredths place is a 6. I look and see I have a 2 coming. That means I round down. So this would round down to 6 cents per ounce. Okay, here I still have a 6 in that hundredths place, but the next number is 5, which means I round up to 7. This is about 7 cents per ounce. Okay, now it's worth noting that had they rounded off to the same thing, I can still tell which one is cheaper by looking at the price before rounding. So, like, let's say this had been 0.064. Okay, well, that would have also rounded down to 6 cents per ounce. So they would have rounded off the same, but 0.064 is still a bigger number than 0.0625. So this would still be cheaper, even though to the nearest cent they're the same. Okay, if this had been like 0.061, okay, it would have rounded down to 0.6, but that would have been a smaller number than this. Okay, so if they round to the same number, make sure you check the decimals before rounding. Okay, and still say which one is smaller. You would only say they're the same if these two numbers are exactly the same before rounding. Okay, not just because they round off to the same thing. All right, that's where we're going to leave it. Good luck.